Alright, in this video, we'll be looking at how to prove this trigonometry identity 2 minus secant square x over 2 tangent x plus secant square x equals to cosine x minus sine x over cosine x plus sine x. So proving trigonometry identity is a very common question in the O-level additional math. So let's try to do this question together in this video. Alright, let's take a look at what we need to prove here. So we have 2 minus secant square x over 2 tangent x plus secant square x equals to cosine x minus sine x over cosine x plus sine x. So if you take a look at this, right, we know that no double angle formula is needed because all of the angles are x. Okay. Then next, right, we see secant square as well as tangent. Is there an identity that you think of when you see secant square and tangent? Well, I'll think of this. So tangent square x plus 1 equals to secant square x. So we'll take a look at using these formulas here. Okay, so let's just start off proving by copying what is on the left hand side. So we have 2 minus secant square x over 2 tangent x plus secant square x. Next, I'll replace secant square x by tangent square x plus 1. So I have 2 minus tangent square x minus 1. Okay, for the denominator, I'll have 2 tangent x plus, so I replace secant square x with tangent square x plus 1. So tangent square x plus 1. Okay, simplify the numerator. I have 1 minus tangent square x, and this one looks exactly like a square minus b square, right? Where a square is 1 square, and your b square is tangent square x. Okay, and at the denominator, I rewrite this to have tangent square x plus 2 tangent x plus 1. So once I take a look at this, right, this one looks a lot like a square plus 2ab plus b square, right? Okay, so remember, if you have a plus b square, you have a square plus 2ab plus b square. Or if I make it even more obvious, if I have a plus 1 square, I have a square plus 2a plus 1, where a looks like my tangent x, right? Okay, and this is basically 1. Okay, so a square is like tangent square x, 2a is like 2 tangent x plus a 1. So I know that the denominator can be rewritten into tangent x plus 1 square. And the numerator is 1 minus tangent square x. It is like your a square minus b square. Or you can also look at it as in terms of a square minus 1 minus a square. Okay, which is 1 plus a, 1 minus a, right? So I'll change my numerator to 1 plus tangent x and 1 minus tangent x. So you notice you have 1 plus tangent x here. You have 1 plus tangent x squared here, or tangent x plus 1 squared here. So I can cancel away one of the 1 plus tangent x. So what I'm left here is 1 minus tangent x over 1 plus tangent x. But what I need to prove is not tangent, right? I need to prove cosine x minus sine x. So how do you change tangent into sine and cosine? Well, remember, tangent is equals to sine over cosine. So I'm going to replace all my tangent x with sine over cosine. Sorry. Okay, and if you compare this, what I have here with what I have here, so basically there is no fraction over fraction, right? So since I have cosine as a denominator here, right? I have cosine as a denominator here. To get rid of it, right, I just need to multiply this entire thing by cosine x and this entire thing by cosine x. And it doesn't affect anything because cosine x over cosine x is 1. So now I'll multiply the numerator by cosine x. Okay? And okay, let me erase this on the right hand side first so that we'll make more space. Alright, so now I'm going to multiply cosine x to 1 minus sine x over cosine x. So cosine x times 1 is cosine x. Sine x over cosine x times cosine x is basically sine x. So in the numerator, I'll end up getting cosine x minus sine x when I expand, which is what I need here, right? Similarly, for the denominator, when I multiply this to cosine x, I'll have cosine x plus sine x. So this is equals to the right-hand side, which is what I need to prove. So I have shown this.